Hello, grade 8 learner. Welcome to another video lesson in mathematics. In this video lesson, we will be discussing how to solve worded problems involving rational algebraic expressions. We will see here how you can use these expressions to solve everyday situations. It's another great day to learn, so prepare your pen, paper, and module as you start watching and learning from this video lesson. Happy learning! This lesson is based on the K-12 curriculum learning competency. The learner solves problems involving rational algebraic expressions. By the end of this lesson, you, the learner, should be able to understand and analyze situational problems, to translate English phrases into mathematical statements, and to follow and apply the steps in solving worded problems involving rational algebraic expressions. Let's begin the lesson. In solving any worded problem, we follow these steps. First, we represent the unknown quantity in the problem with a variable in our mathematical statements. Second, we derive the equation based on our understanding of the problem and our translations of English phrases into mathematical statements. Third, we solve for the unknown quantity using the operations, properties of equality, and mathematical techniques that we have learned about. Lastly, we state the conclusion of the problem by answering the question that the problem asks us. One of the most common word problems involving rational algebraic expressions are what we call as work problems, or problems that involve the work done between two or more individuals. Let us take a look at this example to see how we can use RAEs to solve this problem. Anna can finish all her modules by herself in 6 days. Anna's classmate Brad can finish his modules by himself in 8 days. If they help each other in finishing their modules, how long will they finish their modules? Our first step is to represent the unknown quantities in our problem. The first and important unknown quantity that we should represent is the quantity that we are supposed to solve for, which is the time that it takes Anna and Brad to finish their modules together. That time is represented with the variable x. Aside from representing the quantity that we are solving for, let us look at the ideas in the situation that we can use to solve the problem. The problem describes how long Anna and Ben can finish their modules individually, which helps us determine the rate of work that each person can do per day. From the expression, Anna can finish all her modules by herself in 6 days, we understand that the rate of work she does is 1 over 6, meaning in one day, Anna had already finished 1/6 of her modules. Following the same pattern, the clause Brad can finish his modules by himself in 8 days means that Brad's rate of work is 1 over 8, meaning in one day, Brad had finished 1/8 of his modules. Now that we know the rate of work done by Anna and Brad individually, we have to determine how much of the work they do when they do the work together. To help us organize our representations, we draw a table. In the first column, we identify the student doing the work, Anna and Brad. In the second column, we are going to write down the rate of work that each person does per day. We said that for Anna, her rate of work per day is described as 1 over 6, while Brad's is 1 over 8. The time that they spent working together is unknown, and as we said, we represent it with the variable x. Finally, to determine the part of work done by each individual, we multiply the rate of work that they do with the time that they work together. This means that for Anna, multiplying 1 over 6 with x is equal to x over 6, while for Brad, multiplying 1 over 8 with x is equal to x over 8. Take note of this result as we move to the next step. The second step is to derive or write the equation that we are going to use to solve this problem. To solve for the length of time that Anna and Brad will take to finish their modules together, we have to add the part of work done by Anna to the part of the work done by Brad in order to complete one job. Thus, our equation is x over 6 plus x over 8 equals 1. Now that we have an equation, we then solve for the unknown quantity, which we have represented with x. Our first step in solving for x will be to change the dissimilar RAEs to similar RAEs, or RAEs with the same denominator. Remember that to do that, we solve for the LCD of the denominators first, because we are going to use the LCD as the common denominator for the RAEs. Through factorization, we find that 24 is the LCD that we can use. So in our first RAE, to get 24 in the denominator, we have to multiply 4 to 6. But this also means that we have to multiply the same number 4 in the numerator. Applying the same process to the second RAE, we have to multiply 3 to the numerator and the denominator to make it similar with the first RAE. The previous step will give the following result of 4x over 24 plus 3x over 24 is equal to 1. Since we have now similar RAEs in our equation, we then add the numerators together to get the equation 7x over 24 is equal to 1. We then apply the multiplication property of equality to both 7x over 24 and 1 to eliminate 24 on the left side of the equation and get the result 7x equal to 24. From this equation, we can now solve for x by dividing both sides of the equation by 7 to eliminate 7 from 7x. This will leave only x on the left side of the equation, while on the right side of the equation, we divide 24 by 7, which is equal to 3 and 3 over 7. Looking at the final statement, we can now see that x is equal to 24 over 7 or 3 and 3 over 7. Now that we know the value of x, we now state our conclusion. From our solution, we find that x is equal to 3 and 3 over 7, which means that if Anna and Brad help each other in finishing their modules, they will be able to finish them in 3 and 3/7 days. Were you able to follow the steps in solving the work problem? Let's study another problem to improve our learning. Jack can finish planting pechay seeds by himself in their 1 hectare garden in 18 hours, while Daniel can do it by himself in 14 hours. If they do the work together, how many hours will it take them to finish the work? Once again, the first step in solving this word problem is to represent the unknown quantities in the problem. This means that we identify the rate of work done per hour, the time spent working together, and the part of the work done by Jack and Daniel. Because Jack can finish planting the pechay seeds in 18 hours, his rate of work per hour is 1/18, while Daniel's rate of work per hour is 1/14 since he can do the same work in 14 hours. We are going to solve for the time that they spent working together, so we represent that with x. Finally, to compute for the part of the work that each of the boys do, we multiply the rate of work and the time spent together. For Jack, his part of the work is x/18, while Daniel's part of the work is x/14. Take note of these expressions as we move to the next step. Now we derive the equation that we are going to use to solve the problem. From our previous step, we take the part of the work done by Jack and add it to the part of the work done by Daniel, then equate it to 1 to represent the complete work that they are going to do. Thus, our resulting equation is x/18 plus x/14 equal to 1. We are now ready to solve the problem. First, we change the dissimilar RAEs to similar RAEs by solving for the common denominator. In solving for the LCD, we compare the factors of 18 and 14 so that we can determine that the LCD is equal to 126. This means for the first RAE, to change its denominator 18 to 126, we need to multiply 7 to 18. But doing this means we also multiply 7 to the numerator x. For the second RAE, we multiply 9 to the numerator and denominator because the denominator 14 has to be multiplied with 9 for it to be equal to 126. Doing the operations from our previous step will give us the expressions 7x/126 and 9x/126, which we are going to add to get the equation 16x/126 equal to 1. From this equation, we solve for x by multiplying 126 on both sides of the equation to get the equation 16x equal to 126. Then we divide both sides by 16 so that x will remain on the left side of the equation, while on the right side, we simplify 126 over 16 to 63 over 8 to get 63 over 8 or 7 and 7 eighths. At the end of the solution, we see that x is equal to 63 over 8 or 7 and 7 eighths. Now that we're done with the solution, we now state the conclusion to the problem. Since we know now that x is equal to 63 over 8 or 7 and 7 eighths, this means that if Jack and Daniel help each other in planting the pechay seeds in their 1 hectare garden, they can finish the work in 7 and 7 eighths hours. Were you able to follow the discussion in problem solving that involves rational algebraic expressions? Good job if you did. Work problems are just one type of word problems that you can solve with rational algebraic expressions. So explore in your own time the other kinds of word problems that you can solve using RAEs. If there are some things that are still not clear to you regarding this topic, you can always replay this video, read your module, or ask help from your teacher to improve your learning. Before we end this video lesson, try solving this word problem to practice what you have learned. Pause this video first and solve before we move to the final answer. Done? If you were able to conclude that Alvin and May will finish cleaning the living room in 12 minutes if they work together, then you are correct. Good job! If you didn't, check the solution to see where you went wrong. Mistakes will never be permanent if you take the time to correct them. Congratulations for finishing this video lesson. We hope that you never get tired of learning because, as Leonardo da Vinci said, learning never exhausts the mind. Keep on learning, dear learner, and we'll see you again in our next video lesson.